All right, so exactly how did we get to where we are? We extracted this nifty little booger from this drive assembly. It was heat creeped and all wedged in to the point where the stepper motor couldn't move and the filament couldn't be fed in, and it would not clear using the pin method to clear. So we disassembled the entirety of the heater assembly, the extruder assembly, and we end up with the mounting block, the heater cassette block, the nozzle, and the guide tube. And one of the most common questions you bump into is when you are inserting or replacing the oh, let me back up. Here is the ugly Teflon guide tube. You can see it's all full of something here, and this is the end that was all mushroomed and gross, and that was not going to clear at all. So need to replace this Teflon tube, and a common question is, how long should this tube be? And I've seen 35 millimeters, I've seen 34 millimeters, I've seen 37. The honest to God answer is, well, it depends. It depends on the length of the cut inside the guide tube and which nozzle you have. I am using an aftermarket nozzle. So what I did was put a length of Teflon tube up inside here and bottomed it out, and then took the nozzle and put it on until the two mated. When this was cut long, the nozzle would basically mate up to about here, and you'd have this gap in the middle, and that gap is bad. If you try to tighten this in the threads inside the heater block, you will crush this Teflon tube. It'll mushroom open, it'll grab the filament, and you'll have really poor feeding inside the extruder. So what you need to do is push the nozzle onto here, find out how much length is remaining, take it back off, take a razor blade and cut the end off until this just barely mates touching here. Now, if you mate this up perfect, you're going to have the proper assembly inside the heater cassette block. Now, here's a cross section of the heater cassette block, and you'll notice that the guide tube and the nozzle make contact just in the middle, absolutely perfect. And theoretically, they would both bottom out on the hot block. And okay, that's a good theory. In reality, what's going to happen is one of them is going to be too long or too short, or the whole countersink is going to place you inside the heater block in a suboptimal position. And so you need to accommodate that. Or if you are using an aftermarket or replacement nozzle like this one, this is a stainless steel replacement nozzle, it will be a different bore length and a different overall length and a different shoulder height from threads to this shoulder, to the point where your dimensions change and your tolerances change, and you won't end up with perfect assembly. In my experience, the only perfect thing in this world is my wife. So how do you assemble this? Let's go to the hot block, and we're going to basically, there's a set screw here to retain the heater cartridge in the bottom. We're going to place the nozzle into the bottom, and we're going to tighten him up. Actually, I tell you what, there it is bottomed out. We're going to back him off just a little bit, and we're going to insert the guide tube from the other end and tighten him up until those two touch. There, they're touching, and you're going to notice that I can freely maneuver this heater block around. It's just going to slop around because this guy's touching that guy, and effectively they're too long. And if I tighten the nozzle against the heater block, it will, without rotating the guide tube, it will bind the threads basically inside here. Those two threads are perfectly aligned, and then you're going to wedge them like this. It'll wedge into the heater cassette block, and that's great, but you'll have a gap down here at the bottom where the nozzle is not in contact with the heater block. And I'll exaggerate that here, but you'll end up with a gap like that. And that is really bad because from a thermal conductive perspective, you want all the heat in this block from the heater cassette into this aluminum block to get conducted into the nozzle. If I have to take a path from the heater to the block, through the threads down here. I'm injecting the heat at this point up here, and I'm wasting this opportunity down here. If I loosen, let's loosen everything up. Oops. Loosen everything up, and I tighten the nozzle up against the heater block. It's now in face contact here, which means my heat path is going to go like this. I can come right across the aluminum into the face of the nozzle, get heat into the nozzle where I want it, and then I can tighten the guide back here to bring it flush with the back of the nozzle. Now, it's not going to be face seated here, so ultimately you want to tighten this nozzle against the heater block with a wrench, and then get a wrench on these flats here and tighten the guide, and then reinstall the thermistor and the heater cassette, push the whole assembly back up inside your extruder assembly, and tighten the set screw in the alignment that you want it. You'll notice that on this guide tube, I have tossed it, find good contrast, tossed it in a lathe, and I cut two 1/16 inch grooves, one at the bottom of the wrench flats and one above the wrench flats, to create a thermal break. And here's a picture of a Micro Swiss guide tube assembly that has a very necked down element in the middle. I'm trying to approximate that a little bit. In fact, you could carve the entirety of this wrench flat area off and neck the tube down and make your own equivalent. However, you'd need to put some kind of a wrench flat feature on here somewhere else in order to basically tighten this, because if you don't tighten it with a wrench, it'll loosen up over thermal cycling, and then the whole thing will slop around and screw up your, because it's threaded, if this can move, that's indexing this up and down on the screw threads here. So yeah, basically you're going to put this in, and once you've done that, you're going to bring this flush with the top of this block, so that he sits flat on the extruder drive mechanism, and you'll have to place this guy in here and tighten that set screw with this flush. Ideally, you would redo this every time you change the nozzle, because you want to set the nozzle into the block and then bring this guide tube down to mate here, and then basically bring this back up. The Wanhao factory video shows you just basically yanking the nozzle off and putting a new one in, and that will come pretty close if you're using exactly the same kind of nozzle. But if you've moved from, say, the brass nozzle to the stainless steel one, this one's going to be a completely different length, and you really should adjust the Z offset here to make it flush here and make this assembly made up properly. So you've noticed that I took all of the Kapton tape and what little insulative gunk that was on here off, because, well, I didn't know it was crusty and nasty. So I'm going to take some fiberglass tape, and once I get this mostly assembled, I will basically wrap the block in a couple wraps of fiberglass tape, poke some holes for the appropriate accoutrement, and wire it on with some copper wire, or if I have some Kapton tape, I might use that. But basically put a couple of layers of fiberglass cloth on here, because we want to retain heat in this aluminum block and not just let it radiate out and soak into the mechanism above. All right, so we're going to go do that, and I will get back to you once it's on the machine. So here we are, and it looks like we are printing properly. You can see we got the hot block wrapped in some fiberglass tape, which is that stuff, and you can just take your finger and push the weave apart to clear all of the obstructions. But it is doing well, and we did have to re-level the bed, so you're gonna have to make adjustments to those guys because you moved the print nozzle height relative to the gantry. But otherwise, we look like we're in good shape.